Guys, and welcome back to another video on the channel. In today's video we're going to be taking a look at question 1 from the QCAA Physics External Exam for, I believe this would be paper 2. Now, as you would have noticed with all the questions on the channel, I've started splitting them up into individual videos. That way, if you only struggle with a certain type of question, you can go watch it in the playlist. Otherwise, the full external exam is still up on YouTube, so you can go check that out. If you guys need a physics external exam bundle pack, the link is in the description below to get your download. But otherwise, let's get straight into this guy here. And if you have any questions, leave something in the comments and I'll try my best to answer it, just like every other video. So here, question 1, a charge of 2.8 times 10 to the negative 7 coulombs experiences an electrostatic force of 5.2 times 10 to the negative 1 newtons when it's placed near a charge of 3.2 times 10 to the negative 7. So here, they're asking us to calculate the distance between these two charges. Now, in this situation here, it doesn't really matter if it's a positive or a negative charge, because if it's a positive and a negative charge, they would have an attractive force. If it was a positive and a positive, they would have a repelling force. However, that force doesn't really matter if it's an attractive force or a repelling force. It's still going to be a force. So we don't really need to know if it's a positive or a negative here. Now, this question is a clear example of Coulomb's law, because you're given two charges and you are given a force. Now, it's not exactly Coulomb's law by itself, it's something like this. So you do use the formula here, force equals Coulomb's constant times the magnitude of the charge times another magnitude of the charge divided by the square of their distance. Now, in this situation here, we're given one of the charges. We'll just say this one here is 2 times 10 to the negative 7 coulombs, and then the other one here is 3.2 times 10 to the negative 7 coulombs. Now here, you can look up Coulomb's constant in your data book as well. I believe it does get provided to you, which is 9 times 10 to the 9, and I won't write the units there. Now, in this question here, we've also been given the force. The force is equal to 5.2 times 10 to the negative 1. So realistically, in this formula, we have that, we have that, we have that, we have that, and we are trying to find that. So all we have to do is rearrange to get the r, the distance, as the subject, realistically. So realistically, it's just an algebraic question. It's just realizing what we have and what we don't have. So if I were to multiply both sides by r squared, I would have f times r squared equals k q q. Then I would divide both sides by the force, so r squared equals k q q over f, and then I would square root it. So the square root of k q q and then f. Then we would just chuck in the numbers. So the distance is going to be the square root of Coulomb's constant, which is 9 times 10 to the 9, times by the charge, which is 2.8 times 10 to the negative 7, times by 3.2 times 10 to the negative 7, divided by the force, which is the 5.2 times 10 to the negative 1. Now make sure this is all under the square root and all in one thing, because if you miscalculate here, you won't get probably that final mark there, and it depends if you round it correctly to the two significant figures. So here I'll just chuck it into my calculator. So 9 times 10 to the 9 times 2.8 times 10 to the negative 7 times 3.2 times 10 to the negative 7 divided by 5.2 times 10 to the negative 1. Okay, so this gives us a distance of approximately, this is in meters as well, 0.0393. Now they said they wanted it to two significant figures, so you could write it as a scientific notation. So you can go 1, 2, so you can go 3.9, we'll go 4 times 10 to the negative 1, 2, negative 2. Now because they want two significant figures, you could just write it as like 3.9 realistically or something like that, and that would be your correct answer. If you have any questions at all with this one here, leave something in the comments and I'll try my best to answer it. But otherwise, if you need a physics external exam bundle pack, the link is in the description below. And I'll see you guys in the next video.